Welcome students, we are going to discuss ADP paper from O Levels Chemistry 5070. It is May-June 2023, 42. Question 1. A student investigates the rusting of iron. Figure 1.1 shows the apparatus the student uses. Part A. Name apparatus X. You know that this is a test tube. Boiling tube would have been an acceptable answer here, but the actual answer would be a test tube. State why a stopper is used in experiment B. In experiment B, the test tube contains dry air, and you know that the outer air does contain water molecules in it, as it is moist instead of dry air. If there isn't any stopper, the test tube would get water molecules in it. In experiment C, there is oil of the water, and the question says why it is boiled. Remember that whenever water is boiled, it would lose the oxygen that was dissolved in it. State why a layer of oil is used in experiment C. Due to the presence of this oil layer, oxygen from the outer air will not be able to enter in the test tube. Oxygen from the air is trying to enter the test tube, but this oil layer is preventing oxygen from the air getting into water. The experiments are left for 1 week, predicting which of the experiments the nail will have rusted. For rusting of iron, oxygen and water are required. If you remove any of them, there won't be any rusting. In case of experiment A, the nail is having water as well as oxygen. As both of them are available, so definitely it would rust. In experiment B, there is dry air, that means water molecules are absent. In experiment C, water is there, but it was boiled, so no more oxygen is available in this water. Furthermore, there is an oil barrier preventing oxygen from the air to enter, so no rusting would take place. Both water and oxygen is available to iron nail that were required for rusting. Question 2 is about titration. We are given table to fill. The initial reading for titration 1 is 0.0, while the final reading is 15.2. The final reading for titration 2 is 30.2 and initial reading is 15.2. Subtract initial reading from final to calculate the volume used. In titration 1, it would be 15.2, 30.2 minus 15.2 results in 15. In titration 4, the initial reading is 0.6, while the final reading is 35.1, 2, 3, 4, and 5. So it is 35.5. Try the values in table 2.2 to calculate the volume used. Subtract the initial values from the finals. 35.5 minus 0.6 results in 34.9. I hope you remember that while setting the apparatus for titration, we required a white tile so that we can see the color change of the indicator clearly. So a student required white tile to observe endpoint accurately. Now we are asked to calculate the mean values of acid for both of the experiments at the values of volume used 15.2 plus 15 and divided by 2 to get the mean value. 15.1 is the mean value for the first. For the second experiment, we have values of 34.7 plus 34.9. Add them together, divided by 2, it is 34.8. Use the mean volume of acid needed to neutralize 25 cubic centimeter of A in D to calculate the concentration of ammonia in A. Remember that for calculating concentration or volume, we have formula N equals to CV over 1000. As C is to be calculated and the number of moles are given in the equation, so we would rearrange the formula. This 1000 is being divided here. When shifted to other side, it would multiply with the number of moles and into 1000. As volume was being multiplied, when it is shifted to the other side, it would be divided.
Our crash course isn't just any ordinary study program. It's a game changer. With our expert tutor, the chemistry guru, Professor Faisal Janjowa, and comprehensive curriculum, you'll be equipped with all the knowledge and skills you need to ace your exams. But wait, there's more! Enroll today and get an exclusive 10% discount with code CHEM10OFF. Don't miss out on this limited time offer. Enroll now at www.cambridgeclassroom.com and unlock your full potential.
In the question, in the second statement, it is mentioned that a student titrates 2 samples of aqueous ammonia A and B with 0.5 mole per cubic decimeter HCl. That is the concentration of acid So from the data, we know that for acid, concentration was 0.5 mole per cubic decimeter and the volume was 15.1. So first calculate the number of moles of acid using the formula N equals to CV over 1000, 0.5 multiplied by 15.1 divided by 1000, 0.5 multiplied by 15.1, 0.00755. If you are asked to round it off, you can even round it like 0.0076. From the equation, we can see that the number of moles of HCl equals ammonia. It means that the number of moles of ammonia would be the same as that of acid that we just calculated. To calculate the concentration, number of moles would be 0.00755 multiplied by 1000 from the formula divided by the volume that we are given, that is 25. Input the values in the formula. First multiply 0.00755 by 1000, then divided by 25. The answer would be 0.302. So the concentration of ammonia would be 0.302 mole per cubic decimeter. Calculate the volume of ammonia gas measured at room temperature and pressure dissolved in 25 cubic centimeter. The volume of 1 mole of any gas at room temperature and pressure is 24 cubic decimeter. So actually, we have the number of moles earlier. To get the volume of any gas, we have the formula moles into 24, as the answer would be in cubic decimeter. If it would have been in cubic centimeter, we would be required to multiply with 24,000 in that case. 0.00755 are the number of moles. Multiply them with 24 to get the volume. Use your answer to D and F to calculate the volume of ammonia gas measured at room temperature and pressure dissolved in 25 cubic decimeter. For B, in solution A, the volume was 15.1 and the volume of gas was 0.18. Now we are required to calculate for 34.8. So if it is 34.8, the volume of ammonia would be X. Now cross multiply 34.8 multiplied by 0.18 divided by 15.1. So it is about 0.42 cubic decimeter. The student rinses the beaker with 0.5 mole per cubic decimeter hydrochloric acid immediately before it is filled. Explain why the student should not rinse the beaker with distilled water immediately before it is filled with 0.500 mole per cubic decimeter hydrochloric acid. Diluting the beaker with distilled water would leave some drops of water in the beaker that would affect the results, because the hydrochloric acid would be diluted in that case. So we can write that some water remains in the beaker that would dilute the acid, that is HCl actually. Such is why universal indicator is not suitable for use in this titration. The color change in universal indicator may not be evident, so we can write that the color change would not be as clear. In question number 3, we are given that a student investigates solution W and solid X. Solution W is green in color and contains iron 2 ions. Describe how W can be shown to contain iron 2 ions. Remember that in identification of ions, we test substances with few drops of sodium hydroxide. Later on, we add excess of sodium hydroxide to identify the metal ions present in that. So you would be adding sodium hydroxide. So we can write that add few drops of sodium hydroxide, we would observe green precipitates that would remain insoluble in excess. If you leave it for some time, a brown ring would appear on the top of the surface. Excess W is added to acidified aqueous potassium manganate 7. Describe the color change. Potassium manganate is of purple color. When it is reacted with iron 2 ions, it would form iron sulfate. Due to that, a yellow color would be seen. So the color change would be purple to yellow. Describe the observation made when a few drops of aqueous ammonia and then excess of aqueous ammonia are added to mixture. I hope you remember that potassium manganate is actually oxidizing agent. It would oxidize Fe2 positive to Fe3 positive. That's why when the mixture is tested, basically it would be test for iron 3 ions. We are given the data sheet. Using the data sheet, we can see that red-brown precipitate would be formed that would remain insoluble in excess when ammonia is added. So we would write that when a few drops of ammonia are added, red-brown precipitate are found that remains insoluble in excess. Solid X is a shiny gray metal. The test the student does on X are shown in the table. Some of the observation of these tests are also shown. The student added excess dilute acid to X. In the test tube, the gas produced is tested. The solid disappears. It means that it has reacted completely. The solution remains colorless. No transition matter is there then and become warmer. It means that the reaction is exothermic. For this test, we are given a question. Predict the identity of the gas produced in test 1. As it was a metal tested with an acid, I hope you remember that whenever metal is reacted with acid, it forms salt and hydrogen gas is given off. So basically the gas is hydrogen that can be tested by a lighted splint. When hydrogen is tested with a burning splint, it burns with a pop sound. The observation for test 1 are incomplete. State one other observation that the student makes for test 1. As the gas is given off, so there must be bubbles or effervescence observed. State the conclusion you make from test 2. Dilute nitric acid was added, aqueous silver nitrate. Silver nitrate and dilute nitric acid are used to test halide ions. Solution remain colorless. It means that there are no halide ions present. State the conclusion you make from test 3. Dilute nitric acid and aqueous barium nitrate are used to test for sulfate ions. White PPT confirms the presence of sulfate ions. You can check it from the sulfate ions test given in the datasheet. When a sample is acidified with dilute nitric acid, then barium nitrate is added. White PPT would form if sulfate ions are present. Identify the acid used in test 1. Sulfate ions are present in sulfuric acid, so the acid is H2SO4, that is sulfuric acid. Suggest the identity of metal X. A dilute solution of sulfuric acid was used. It means that the metal must be reactive. The metal can be magnesium or zinc.
Enroll now at www.cambridgeclassroom.com and unlock your full potential.
Question number 4. Baking soda is used to make bread rise. When baking soda is heated, it decomposes and carbon dioxide gas is released. Baking soda also decomposes gradually when it is stored. The longer the baking soda is stored, the less carbon dioxide it releases when it is heated. Plan an investigation to show which of two different samples. So we are having two different samples, say A and B. A baking soda has been stored for longer. So we need to tell that whether A was stored for a longer time or B. And for that, this line is very important. The longer the baking soda is stored, the less carbon dioxide gas it releases. So carbon dioxide gas is released. We can measure it, we can collect it and measure it. Baking soda is a solid, so we can weigh it. Your plan should include the use of common laboratory apparatus and 2 samples of baking soda. No other chemical, so that we need not to use any other chemical to test. Your plan should include the apparatus used, the method, the measurements, the variables to control, and how to use the results to determine which sample has been stored for longer. You may draw a diagram to help you answer the question. We would be requiring conical flask where you can place samples. Baking powder, we need to measure the mass, so we would be requiring a weighing scale. We would be preferring a digital because it is more accurate. So we would be measuring the change in mass of the reactants as carbon dioxide gas would be given off from the reactant. So the mass must decrease. The decrease in mass can be calculated by placing the conical flask on a digital scale, having a sample in it, as baking soda would produce carbon dioxide upon heating. To heat that, we would be requiring Bunsen burner. To measure the volume of the gas produced, we would be requiring the gas range. The gas range would be attached to the conical flask. It would be airtight by bung. This is the gas range. This one is delivery tube. And this one is stand that is placed to hang the gas range in the required position. If you want to draw the figure in the paper, this figure is sufficient. You can even add Bunsen burner here to provide heat, or you can place a digital balance under it to measure the mass. These are the bungs required to airtight, as we are using only one delivery tube, so we would be requiring this bung to measure the time. We require a stopwatch. We can use digital or analog, but I would prefer the digital one. This is the overall apparatus that we can set. We can place a sample of baking soda in the conical flask, connected to the gas range via a delivery tube. Airtight the container using bung and a measuring scale to measure the decrease in mass. You can even measure the mass of baking soda before and after the reaction. You can even draw the graph to see that which sample has produced more volume, but that isn't required. First of all, we need to have two samples of baking soda of equal masses. For that, we would be requiring a balance. Now we have, using balance, make two samples of baking soda of equal masses. Now we have two samples that we can place into different conical flasks, or we can use the same to perform the experiment twice. Add this sample to the conical flask, attach a gas range to it using a bung, delivery tube, and a stand, as we have seen in the figure. Heat it with the Bunsen burner and note the time using a stopwatch. Stop heating and note down the gas collected in the gas range. Measure and record the mass of conical flask along with this sample of baking soda inside it. Now repeat this experiment with other sample, making sure to provide the same heating level for the same time, that is 5 minutes, and record the readings after that. Compare the readings. The sample that has produced less amount of carbon dioxide was stored for longer.
Attention all IGCSE Chemistry Euro 622 and O-Level Chemistry 5070 students. Are you feeling overwhelmed by the thought of tackling the upcoming chemistry paper? Are you craving that feeling of confidence and success as you walk out of the exam hall? Fear not, because we have the solution to all your exam worries. Introducing our IGCSE Chemistry 0620 and O-Level Chemistry 5070 crash course, the ultimate guide to conquering your exams with flying colours. Imagine the joy and pride of achieving the grades you've always dreamed of. Picture yourself opening that envelope to find the results you've worked so hard for, knowing that all your effort has paid off. Our crash course isn't just any ordinary study program. It's a game changer. With our expert tutor, the chemistry guru, Professor Faisal Janjowa, and comprehensive curriculum, you'll be equipped with all the knowledge and skills you need to ace your exams. But wait, there's more! Enroll today and get an exclusive 10% discount with code CHEM10OFF. Don't miss out on this limited time offer. Don't wait until it's too late. Enroll now in our IGCSE Chemistry 0620 and O-Level Chemistry 5070 crash course and take the first step towards exam success. With our proven track record and dedication to your academic excellence, there's no limit to what you can achieve. Join us today and let's make your exam dreams a reality. Enroll now at www.cambridgeclassroom.com and unlock your full potential.